Setting up a physical switch, a Cisco switch. This is Joe with Router Freak, and today we're going to get into some really cool stuff where we actually begin initial configuration on our Cisco switch. We're going to go through looking at the physical indicators on the outside of your switch to make sure that we understand from a physical perspective from outside what's going on with the switch. We'll then go under the hood and look at the boot process as we boot up a real switch, and we'll walk through to show you exactly what's going on. And then finally we'll get into some of the initial configuration for our switch. So when we first start talking about our switch, I'm going to use a 3550 as an example because that's what I have here. Now every switch is going to be a little different. Their status indicators will change depending on the model of switch that you have. For this example, a 3550, well, the 3550 and the 3560 has really informative front end that with this mode button allows you to view the status, utilization, duplex, and speed of the switch, and it's all reflected across the top in on our interface status lights. So on a 3550 or 3560 switch, you'll have, say, 24 or 48 ports, and each port will have a status indicator to indicate whether it's active or not active. And this mode button here, if you push it, will change the status of these lights across the top to either indicate speed, could indicate duplex, they could indicate utilization, or just plain status. So when you pull your switch out of the box, you're going to turn it on, and the first thing you should see is all the lights should light up green, including this system LED. And this system LED should stay green. Green is good. After it's booted up, green is good. If this system LED is any other color, if it goes amber, if it flashes or anything after it's been booted up, then by all means you should pick up the phone and give TAC a call and let them know what's going on, because you may have a switch that is DOA, or dead on arrival, so you want to check that out. The RPS LED is for redundant power supplies, and the redundant power indicator will show you whether your redundant power is functioning properly or not. And the redundant power, like an RPS 300, is like another 1U rack mount system that could go either above or below your 3550 and provides redundant power for your switch. Press your mode button again and it'll show you the status, which is whether your ports are up or down. Press it again and is utilization. With utilization, the number of LEDs that light up indicate how utilized your switch is. So the more of these that light up, kind of think of it as a like a graphic equalizer on a stereo or something. The more the more of these that light up across the top will show you how much more utilized the switch is. Duplex, if you press the mode button again, it shows you which ports are in full duplex versus half duplex. And then speed, of course, will show you which ports are 100 megabit and which ports are 10 megabit. And again, not all the switches have the same status indicators. So if you were to have if you were to purchase a 3750 switch, these status indicators are going to be completely different. So you want to familiarize yourself with the documentation that came with your switch and what those status indicators mean. Okay. So now I have a 3550 here right next to me, and the best way I think to show you guys what's going on with the switch is that we're going to boot it up. So let me I pull up my TerraTerm here, and I'm on COM 4 is where I'm at. That's where my switch is. For my computer is COM 4. So I'm going to connect to COM 4, and let me get it. Let me size this window a little bit here, if I can, just so we get it right. All right. So give me 1 second. So I've turned my switch on, and on the outside of my switch I have all green LEDs, which is a good sign. And there we go, there's the boot process. So if you notice, we've got a bootloader, and it shows us the version of the bootloader, shows our MAC address. See if I can make this just a little bit bigger. We have some copyright, and I'm going to go through this because it's all flowing by pretty fast. These post messages, that's a power on self test, and you notice everything passes as we go through all the different circuit boards that are in the switch. It runs through a post or a power on self test for each of these devices. So now if I go back up here, I want to show you some stuff. So here, well, I may have to wait for this because it's going to keep scrolling. But if you noticed here, there was a bunch of hash marks or a bunch of pound symbols. There's our system serial number that just scrolled by, and this is what we have. Oh, I'm sorry, I 3550. It's a 3548, 355048. So let me go back and let me kind of review what we've done here. Okay, so we see our flash, we have our boot sector. Now this right here is the system finding in the flash this image, and this is the iOS image that it found, and what it does is it uncompresses it and then loads it all into memory, and that way it will run faster. It runs much faster when it's in memory than running from flash, which would be bad. When we have the copyright, we have some copyright information here, and then we see that we're running a 3500 XL. This is the version. More copyright, and then we go through our self-test. It does a little check of the flash file system, make sure the flash file system is okay. Does an FS check. If you're familiar with Unix or Linux, a lot of what we do with switches and routers is going to be very familiar to you because a lot of the commands and a lot of the syntax is very, very similar. Okay. And then as we scroll down here, we see the processor, the board ID. This is serial number on the board, the hardware itself, the motherboard itself. See, it's running Enterprise Edition. We have 48 fast Ethernet ports and 2 gigabit uplinks. We see our flash. Here's our MAC address. This is the MAC address of the switch. Here's the exact model number of the switch, and here's the exact serial number of the switch. So if you have a support agreement like SmartNet or whatever on your switch, this is the serial number that should be in SmartNet for your switch. It shows you that the last time the system restarted was from a restart or from loss of power. And then finally what we do is we come down here at the bottom and continue with configuration dialog, yes or no. Now what we have here is with the system configuration dialog, you can think of it as a wizard, or it's a menu system that prompts you through initial configuration for your switch. So you can say yes or you can say no. These are the defaults. So if you don't do anything here, if you don't say yes or no, it's going to prompt you again and again until you say either yes or no. So anytime you see in brackets like this something, it's asking you, it's expecting here either a yes or a no. So 99% of the time you're going to say no. This configuration dialog is really for people who maybe aren't as familiar with Cisco switches. They've never configured one, and so what it'll do is it'll walk you through every step of the way. So if I type yes, and you'll see what I mean. So the first thing it asks for is it wants me to enter an IP address. Enter IP address of the box. So I could say 192.168.1.254. 1.254. There we go. So if I enter that in there, then it's saying, okay, now I want a mask. What's the mask for this network that the switch is on? Do I want to enter a default gateway? So here, if I don't put anything, notice right here, see how it's in brackets and yes. If I say anything but yes is not the default. The default answer is yes. So if I just hit enter, it's going to say it's going to assume that I want yes. So because I just hit enter, the default answer is yes. So what's my default gateway? 192.168.1.1. Enter the host name for the switch. The default host name for any Cisco switch is just switch. Now I could say Joe's switch here. There's Joe's switch. And that'll change the name. Enable secret is a one-way cryptographic secret for my enable password. My enable password. And we'll get into the modes of the switch, the different types of modes. So secret, I can say password. That is not a good enable password. That's a bad enable password. You want a password that has at least one, if not two numbers, and maybe some special characters. You want to maybe have some capital letters in there, and you want to mix it up. You do not want a dictionary word. Password is a word that can be found in a dictionary. You can hack that password so fast. Do you want to configure a telnet password? So this is a password for the virtual terminal or for the telnet. So my telnet password, I can say, is password. Would I like to enable the cluster command switch? So now with this particular switch, it can function in what is known as a cluster, and that means it's a stackable switch. So this switch there's a back end cable that you can connect a whole bunch of these, up to 8 of these switches together, and they work together as one logical switch. So I'm going to say no, I don't want it. So there's a lot of my the basic. Here's some of the basic outline of what it's going to do, what it's going to configure. Am I going to use this configurator? I'm just going to say no. And if I say no, it brings me right back to the wizard. So I'm just going to dump this out, and I'm going to say no. And normally this is what you would do. You would say no, because you really don't want to necessarily run through this wizard, because you're going to want to configure this yourself. You may have the entire configuration that you've already written out. And especially if you're deploying 50 of these switches, you're going to have a configuration. You can just paste it in, blam, in one swoop, and you can move on rather than have to go through one line at a time. So here's my switch. I've gotten in, and the name of the switch by default is switch. So there's a lot of things. When you first get into a switch, you're in what is known as user mode, or non-exec mode, non-enable mode. The technical term is user mode. And in this user mode, you notice the prompt here. See how it's like a caret? That caret indicates that greater than symbol indicates that you're in user mode. So let me go back real quick to my PowerPoint. So as we went through the boot process, we kind of saw what was going on during the boot. There was an initial boot image, a boot OS, that when you first turn the switch on, it loads this little mini operating system from RAM that's built into its firmware. And then what it does, it's kind of like your BIOS on a PC, right? And then what it does is it looks to the flash file system for an operating system. Just like with your PC, it'll look to the hard drive for your Windows operating system. Well, with a router, it looks to the flash file system for an iOS image to boot from. Then once it boots, it's going to expand, it's going to decompress that image, and it's going to load it into memory so you can use it, so it's much faster, and then it's going to run into the initial setup. Okay, if you say yes, we're looking at a wizard type scenario. If you say no, then we're going to configure it manually. So one of the things that we do when we configure things manually, we're going to configure a host name, you want to configure an IP address, and you want to configure a VLAN. So let me go back, okay? Let's go back to our dialog here. Now, remember in the last module we went over all the different help commands, and that is if you hit question mark, you can see the help system. Okay, enable was a different mode, right? Enable mode is the exec mode or the privilege mode, and I can enter a question mark there, and it gives me a different set of commands that I can execute from enable. Now what we're going to do is we're going to go into global configuration mode. Remember, that's config T, config terminal, and what we want to do is we want to give our switch an IP address. Okay, so to give our switch an IP address, we can say IP, and look, there is no IP address, is there? So what do we need to do? I'm not really sure what we need to do. So let's back up a little bit. Control Z will back us out. Remember that from our last module. And we can do a show run, or I abbreviate it to be just sh run. So we have all our ports here. VLAN 1, con, and then the end. So what we need to do is in VLAN 1, we need to give VLAN 1 an IP address. So you may be thinking, well, why do I need to give VLAN 1? I don't understand this VLAN. What is a VLAN? I'm a little unsure about this VLAN business. So let me explain what's going on with the VLANs. So, and this really you don't have to know until the next till ICND2, but I really wanted to kind of go over it a little bit just so you kind of are familiar with what a VLAN is. So here on our this is a 6500 switch, and notice each of these switch blades here we have a fast Ethernet, 3 fast Ethernet blades, and each of these, oops, sorry, hold on, malfunction, okay, I need my pen color, don't I? Alright, there we go, my blue. So each of these blades here are 48 ports, and by default they're all configured as VLAN 1. They're all configured as VLAN 1. Now VLAN, the term VLAN stands for virtual LAN, or virtual local area network. And just as that sounds, we can split these, we can segment these switch ports into their own virtual LAN. Now, if you want to think of it as, remember how with a switch, each port is its own collision domain. Well, what a VLAN does is a VLAN will break these up into their own broadcast domain. So a VLAN is a broadcast domain. And remember what segments a broadcast domain is essentially a router. And what we want to do is, so we take these ports and we put them all into VLAN 1, and we give VLAN 1 an IP address. As soon as we give VLAN 1 an IP address, that becomes the IP for this broadcast domain. So all the ports that are in VLAN 1 are in the same broadcast domain, and this IP address that we give VLAN 1. So any of the computers that we connect to VLAN 1 or to the ports that are in VLAN 1, we will give them a default gateway of VLAN 1's IP address on the switch. Now we can have as many as we want. Like we could have this group over here be VLAN 2. This group over here can be VLAN 3, etc. And what we end up doing is we're breaking up our switch into multiple broadcast domains, multiple segments that all these computers can sit in. They all have the same gateway, that is VLAN 3. Now, the one thing I wanted to make sure that you fully understand is that you can have a VLAN on a switch, and then you can have an interface VLAN on a switch. And I want you to understand that a VLAN and a VLAN interface are two different things. So a VLAN, we can have VLAN 100, or in this case we have VLAN 1, right? We have VLAN 1, and that has a name of, just give it a name, just call it data. So all of our data rides on VLAN 1, and maybe VLAN 100 is our voice. Maybe we have some VoIP phones on our network. When we create a VLAN interface, we do int VLAN interface VLAN 1, and then we can give it an IP address. And that's the IP address that we will use for VLAN 1. So if you notice, okay, the big difference here, this is layer 2, this is layer 3. The VLAN interface is a switched virtual interface, an IP address, a layer 3 address for our layer 2 VLAN, if that makes sense. So now let's go back to our switch, and we notice here we have VLAN 1, interface VLAN 1 there's no IP address on this. So if I do I have to go into, right now we're in global configuration mode. I need to go into the interface configuration mode, so I do int, or I can just say interface VLAN 1. Now I'm in config if. I'm in interface configuration mode, and I can now give it an IP address. So if I use my question marks, IP question mark, notice we have over here, we have address. We have address. So we can give it an address, IP address question mark. It's the IP address. So we need 192.168.1. What did we say we were going to call it? Give this 1.254. Incomplete command. What are we missing? Let's use our question mark again. We need a subnet mask. So what mask did we say we were going to give this? 255.255.0. There we go. So now if we type end, which will get us out, and we can do a show run again. There's all our switch ports. And notice we now have on our VLAN, here's VLAN 1, and it now has an IP address. So we can do a show interfaces, and now we see VLAN 1. If we look up here, VLAN 1 is up, the line protocol is up. Let's do a show run again. See, now what I wanted to show you, if I do a show VLAN, see, this is just looking at the VLANs now of our switch. I did a show VLAN, and here's VLAN 1. VLAN 1, and the name that VLAN 1 is default, because that's the default VLAN. Every switch comes with a default VLAN, and the default VLAN is VLAN 1, and the name it's given is just default. And if you notice, by default, all ports are in VLAN 1. When we did a show run, we don't see that. We don't see that they're actually in VLAN 1. It's a default command. It's a default configuration. So we don't see that default configuration, but actually every single port is by default in VLAN 1. So they're all in the same VLAN, which means they're all in the same broadcast domain, right? So no matter what we plug into any of these ports, they're all going to be in VLAN 1, and their default gateway will be VLAN 1's IP address, which is 192.168.1.254. Does that make sense? And then before, of course, when we configure a switch, anytime we leave, we make sure we do a write mem, or another command for that is copy running config startup config, and the file name is startup config. I don't know why. If you notice again, here we have it in brackets. is the default configuration. And really, if you name this, if I hit enter, it automatically named that the default, which was startup config. If I name that anything else, it's not going to use that config. So it's really kind of silly that I guess, you know, you can have that as an option, just maybe backup config or something, but you want to make sure that you keep the default there, because if you don't use that default, the switch will not use that to start up with. So where are we? So we saved our config, and we did that by doing a copy running config startup config. Or another way of doing that is to do a write memory. Now, Cisco for years has been saying that they're getting rid of the write memory command, the write mem command. I think it's, well, ever since I've been working with Cisco routers and switches, which has been, 10 years, 15 years I've been working with routers and switches, and for that entire time Cisco's been saying they're going to deprecate the write memory command, but they haven't done it. The one thing that we haven't done so far is the show version command. So let's do that now. Show version. And if you look at our show, when you do a show version, some cool things that you see when you do a show version is if you want to see the model number that your switch is running, you do a show version. If you want to look at the uptime of your switch, notice this switch has been up for 21 minutes. I've been talking for 21 minutes. So the switch has been up for 21 minutes. If you want to see how long it's been up. If you want to look at what iOS image the switch is running, you do a show version. You want to see the processor, the board, what else? Number of Ethernet ports, number of gigabit ports, the base MAC address, all this stuff. And you notice all of this same information we saw on boot up, didn't we? When the switch first booted up, we saw all this same information. Here's the serial number of the switch. All of these things, you may be asked on the test, what do you need? What command would you use to find the serial number for your switch? What command would you use to determine the iOS image that's running on your switch? What command would you use to see how long your switch has been running? All that information can be seen by using the show version command. It's a very, very helpful command. You'll use it a lot. So that's the gist of it. What we did today is we looked at a lot of stuff. We opened up, we unboxed our switch. We looked at the physical indicators that you can see when you first turn on your switch. We looked over the boot process of the switch, and then we also did some very basic initial configuration by giving our switch an IP address and a subnet mask. That is just the very, very basic stuff that we can do on a switch. I hope you've enjoyed this module. We're finally getting our hands dirty. We'll look forward to talking to you next time. Again, this is Joe with Router Freak. I'll see you again. Bye-bye.